Hi everyone. Today we're going to continue in Unit 6 with our Lesson 3, and we're going to talk about reasoning about contexts again with tape diagrams, but this is part 2. So if we look at our first section, it's called Find Equivalent Expressions, and I just wanted to go over this quickly to review a couple of things. They're asking you to select all the expressions that are equivalent to 7 times 2 minus 3n, which is 3 times n, and explain how you know that each expression that we select is equivalent. So the first thing I want to look at is, well, what can we do with this expression to put it in a different form? Because I'll bet you they're not going to just put 7 times 2 minus 3n in there as one of the choices. And it looks like they did not. So one of the things we talked about earlier is distributing the 7 using distributive properties. So if we do 7 times 2, we're going to get 14. And if we do 7 times negative 3n, we're going to get a negative 21n. So that's one of the things we can look for in our answers. So let's see what we've got here. We have 9 minus 10n. Well, what does it look like they did to get that answer? It looks like instead of multiplying by 7, they added 7 in here. 7 plus 2 is 9, and 7 plus negative 3 does not equal. But it looks like they just added 7 to each of these, which does not work. So that is not equivalent. We have 14 minus 3n. Well, what did they do here? They multiplied 7 times 2, but they forgot to multiply 7 times that 3n. So that's not going to work. We have 14 minus 21n, which is what we got when we distributed. So that is correct. And the reason that's correct is we use distributive property. Distributive property. And distributive property means if you distribute the 7 amongst everything in the parentheses, you're going to get an equivalent expression. Here they have 2 minus 3n. Well, look at that. That is the same thing that is in this parentheses, 2 minus 3n, and then they're multiplying it times 7. Well, all they did was they took the 7 here and put it on the back side. And we know that you can do that because multiplication is commutative. So through the commutative property, we know this one is also true. And what's that saying is if I take the parentheses out and give you a simpler multiplication problem, if we have 2 times 3, we know that is the same as 3 times 2. And this is showing the commutative property. Okay, and basically that's what they did. They took 7, our original problem was 7 times 2 minus 3n, and they instead switched them around and they have 2 minus 3n times 7. So this one is true because of commutative property. The last one says 7 times 2 times 3n. Well, because this 2 minus 3n is in parentheses in my original problem, you cannot separate each one. This is not the same problem. It's not the same expression. So only number 3 and number 4 are the same up there. Let's move on to our second section. And they're going to ask us to match the tape diagrams to the equations down below. So I'm going to get just enough of my screen showing that we can get all of them in there. And they want us to be prepared to explain how the equation matches the tape diagram. So let's look at each equation individually. So we have 2x plus 5 equals 19. So we need something with 2 different x's. And then those 2 different x's are being added to 5, and altogether we have 19. Well, here we have 19, but we have 1, 2, 3, 4, 5 sets. So 5 sets of x plus 2, so that's not 5 sets, or 2 sets of x, so that's not going to work. We need something with 2 sets of x, which looks like it might be A or B. So let's look at what we have here. Here we have x plus 5. So over here in A, we have really 5 plus x equals 19. And we learned in our earlier lesson that if we see something being added to itself more than one time, we can change that to multiplication. So we have 5 plus 2 times x equals 19. So it looks like for this first one, A matches for sure, but I see that in B, we also have something similar, only the x's and the 5 are reversed. So in B, we have x plus 5 equals 19. So in this one, we have 2 x's, so 2 times x plus 1 5 equals 19. Well, is this the same as 2x plus 5? And in this case, because both the 2x and the 5 are both positive and were being added together, it is the same equivalent expression. And it doesn't look like we have, let's see, C has 1, 2, 3, 4, 5 x's, and we only have 2 x's. And then D has an x plus 5 2 different times. So that one's not going to work either. So let's move on to our next equation. We have 2 plus 5 x's. Well, I just saw that somewhere, and it looks like it was C. C has 2 by itself, and it's adding x 5 different times. So instead of x plus x plus x plus x, we will do 5 times x, and that will equal 19. So it looks like for sure C works for this one, but let's just check. D doesn't have 5 times x, and E doesn't have 5 times x because it has the 2 with every x. So that one won't work either. So let's look at our next one. The next one says 2 times x plus 5. So we need to find something with this x plus 5 together, and we need it 2 different times. So this is x plus 2, so that's different than x plus 5. Here's x plus 5, and it is there 1 time, 2 different times. And added together, that equals 19. So this one is going to be D. And then this one is x plus 2 5 different times, which I think we saw. This is 1, 2, 3, 4, 5 x plus 2's, and that one is going to be E. Okay, this one has 19 equals 5 plus x plus 2. So now they're just trying to get tricky by reversing the order. We are looking for something with 5 by itself, and then they're adding 2 different x's. So that's something like this one here. 5 by itself, adding 2 different x's, and together that equals 19. So this one is the same as our first one. A and B will match, only what they did was they put 19 on the other side. So instead of putting equals 19, they started with 19 equals the equation. The next one says x plus 5, so we need something with just this x plus 5, and they're multiplying it twice. So x plus 5 2 different times, and we saw earlier that that is D. Okay, it looks like they're reversing that 19 again. They're putting the 19 on the left instead of on the right, and they have x plus 2 5 different times. Well, the only one that's had x plus 2 5 different times is E. So as you can see, it doesn't matter if the 19 is on the left side or the right side, the expressions or the equations are still going to be equal. So this one gets a little tricky because we've got 19 divided by 2. So if we take 19 divided by 2 equals x plus 5. So we need to figure this one out. So we need to find an x plus 5 multiplied by 2, which is this D up here. So D is x plus 5. So we have this x plus 5 equation or expression here. And it's being multiplied twice because there's 2 of them, 1, 2. So this we found out is 2 times x plus 5 equals 19. So in an earlier lesson, I showed you how you can distribute the 2 to both entities in the parentheses. And another way of solving this is you basically have 2 different numbers here. You have a 2 and you have an x plus 5. So before you distribute, you can't do it after you distribute, but before you distribute that 2 to everything in here, you could divide by 2. And if you did that, 2 divided by 2 is 1, and you would have x plus 5 by itself over here. But if you did that, whatever you do to this side, you have to do to this side. So this over here would be 19 divided by 2. And then you could figure it out from there. But what they're showing you here is this 19 divided by 2 equals x plus 5. That's one of the steps that you would take to solve for D. So that is equivalent to D. We're going to have to look again. Looks like they've done another step. So we have 19 minus 2 equals 5x. So we need to find one of our equations that had a 5x in it. And I believe that was C. So if I look at C, I've got 2 plus 5x. So I have a 2 by itself, and then I have 1, 2, 3, 4, 5. I have an x 5 different times. So I'm going to show that by 5 times x. And that equals 19. So the first step in solving this would be to get rid of the 2. So I'd subtract 2 from both sides, and I would get 2 minus 2 is nothing. I would have 5x by itself, and what I have over here is 19 minus 2. And what they're doing here is they're showing you one of the steps. So that would be letter C. So it's important to know how you can solve these different equations when you're looking at the equations split up in different steps. The last thing they're asking you to do in number 2 is to sort the equations into categories of your choosing and then explain the different criteria. I'm going to get a different color for this. This one you can do in a variety of different ways. So one way that I can see is looking for things that you can use the distributive property on. So if I look at equations I can use the distributive property, I'm going to write distributive property. Okay, so if I have equations that can use the distributive property, I would have I'm just going to list them. I would have D. Well, I don't want to list them. Let me do it this way. Let me write out the equation. So I've got 2 times x plus 5 equals 19. That's one I could use the distributive property on. 5 times x plus 2 is another one I could use distributive property. Looks like I could use the distributive property on x plus 5 times 2 equals 19. And then I could use it on 19 equals x plus 2 times 5. So there's one group. The other group, I'm going to put in a different color. Let's use green. And these ones are ready to solve equations. So the equations that are ready to solve would be things I don't need the distributive property for, which would be 2x plus 5 equals 19. 2 plus 5x equals 19. The next two I'm going to skip. I've got 19 equals 5 plus 2x. And lastly, let's see, I've got 19 divided by 2 equals x plus 5. And I have 19 minus 2 equals 5 times x. So one of the ways you could sort those is equations that need to use the distributive property, and then equations that don't use the distributive property. Another way that I see there's different equations is some of these have the 19 on the right side, like these, and then others have the 19 on the left side. So that's another way you could choose to sort them. These have the 19 on the left side. So there's a lot of different ways you could sort them. They just are trying to get you to look at the different equations in different forms and see that some of them could be equivalent. Our last section of this lesson is drawing tape diagrams to represent the situations. And that's exactly what they're asking you to do, is draw the tape diagrams and then use whatever method you want to find the values of x and y that will make those equations true. So let's start with the first one. The first one says we have 3 times x plus 18. And all of that together is going to equal 114. Well, I'm going to start with our constant. I know we have 18 by itself. So there's my box for 18. And then I know we have x 3 different times. So I'm going to add on 1 box for x, 2 boxes for x, and 3 boxes for x. X plus x plus x. And I know that altogether, this equals 114. So that's one way of drawing it. Another way of drawing it would be to do the 3x's first, since the 3x came first in our equation. So there's 3 x's, and then here is my 18. And again, altogether, that's 114. So either one of those will work. And then they are asking us in number 2 to solve those. So I'm gonna use algebra to solve that. I'm just gonna rewrite the equation. And I know that the first thing I need to do is get rid of this 18 because it's being added to my variable. So to get rid of a positive 18, I'm gonna subtract 18. Whatever I do to that side, I have to do to the other side of the equation. So 18 minus 18 is nothing over here, so I have 0, but I do have my 3x still on this side. And then I have 114 minus 18 on this side, and 114 minus 18 is 96. So I have 96 equals 3 times x. 3 is being multiplied times x, so I know that I need to divide by 3, and whatever I do to that side, I have to do to this side. 3 divided by 3 is 1x. I'm going to move over here, 1x, and that equals 96 divided by 3. 3 goes into 9 3 times, 3 goes into 6 2 times, so it's 32 equals x. So there's my first one. I'm going to get a different color for the second one. I'll use this pink just for fun. All right, so the second one is 114 equals 3 times y plus 18. So basically, I have a y plus 18 3 different times. So there's 1, here's 2, and here is 3, y plus 18. And all together, I know that I have 114. So I'm going to move over here so I have a little more space. I have 114 equals 3 times y plus 18. Okay, so I just want to look at this tape diagram a little more closely before I move on to solving that. So basically what they're saying here is you have a y plus 18 section 3 different times, and that's where you get 3 times y plus 18. It's not y 3 times in 3 separate boxes and 18 3 times in separate boxes. This y plus 18, because it's in these parentheses, that is considered one term. So if y equaled 2, this term would be 20. If y equals 5, this term is going to be 23. Okay, so it's important that whatever is in parentheses, you keep in the same box as one term. So to solve this, again, I can do one of two things. I can do distributive property, or I can start by dividing this 3. I'm going to show you both ways because I like both ways in different instances. If you divided by 3 here, you would divide this whole side by 3, and whatever you do to that side, you'd have to do to this side. 3 divided by 3 is 1, so on this side, the only thing I have left is this y plus 18. 114 divided by 3 is 38. So now I have 18 being added to my variable. So to get rid of that, I would subtract 18, and I would have 18 minus 18 is 0. Over here, I would have y by itself, and then 38 minus 18 is 20. So y would equal 20. If instead of doing that, I want to use distributive property, I would do, let's see, I'll get over here, 114 equals 3 times y plus 18. What's happening here? Okay, let's try it again, plus 18. There we go. So instead, I would distribute this. I would have 3y, 3 times y is 3y, and 3 times 18 is 54. And all of that equals 114. So now I would have to get rid of my 54 by subtracting it. Whatever I do to that side, I have to do to this side. And again, over here, I would have 114 minus 54 is 60 equals 3 times y. 54 minus 54 is 0. Then I have the 3 with the y. It's being multiplied, so I would have to divide. Whatever I do to that side, I do to this side. So I have 20 equals y. So either way, you're going to get the same answer. If you start by dividing, it's you're kind of eliminating a few more steps. So again, let's look at our summary of this lesson. The summary is talking about seeing different tape diagrams, and they're talking about seeing 2 different ones here. They're giving us 2 examples. This first one with 26 and 4 different x's, they're saying you can describe it in different ways. You could see this as 26 plus 1, 2, 3, 4 times x equals 46, because you put those in the same exact order. You could also see it as 4x plus 26 because addition is commutative, and commutative means like our equation families. If I had 3 plus 2 and that equaled 5, that's the same as 2 plus 3 equaling 5. That's commutative property, and that is true with addition. You could also put the whole on the other side and do 46 equals 4x plus 26. And then they're showing you that you could start by showing some of the steps of solving the equation to show that it is also equivalent that way. The next sample they're showing us is the set with parentheses, basically. This x plus 9 is one term. This is one whole term, and this is one whole term. So it's not 4 different x's plus 4 different 9s. This is one term. So they're showing you this way because you've got 4 times one different term. This is no different than if I just had an x in here by itself, because I would have 4 times x, or 4 times x plus 9. So we need to be careful that if there's one thing in a group in this box, we need to keep it together as a group. And that is our lesson for lesson 3 of Unit 6. I hope you guys have a great rest of your day.